Welcome back, Chem students. Now we're going to be looking at graduated cylinders and accuracy and precision and reading them. They can be a little bit more tricky than a ruler because they come in many different sizes and shapes. So reading what the different values are on the side of the graduated cylinder can become crucial. So for example, with this graduated cylinder that I just put up on your screen, it is showing that 20 is right here. So the number is sitting right above the line, and then this is 25. So what you need to determine is what do each of these little lines represent? And if you'll notice, there are 10 of them, but you're only going up. All right, as I was saying, there are 10 lines between them. So that tells you that each line is not representing 1, but it's representing 0.5. So for example, this line right here is actually 21 mils. This one is 22, 23, 24. So when you're reading a graduated cylinder, you always read from the bottom of the meniscus. And this is a property about water, that it is attracted not only to itself through hydrogen bonding, but it's also attracted to the sides of the walls of the container that it's in. So you're going to read from the bottom of the meniscus, not from the top of the meniscus. So not from here, but from the bottom. From the bottom of that meniscus, you know for sure that you are at at least 21 milliliters because it's above this red line. You know it's above 21.5 milliliters. So now you're just going to estimate, is that right at 21.5 or is it maybe 21.6? And in my estimation, it does look slightly above. It might be the picture or the angle that I'm looking at it. So I'm actually going to estimate that this graduated cylinder is measured to 21.6 milliliters as my measurement. Let's take a look at another one. This graduated cylinder is a little bit different, and this is where when you pick up a graduated cylinder, you're going to have to figure out what do each of the lines mean. So once again, this right here is the 50 mil mark. This one right here is the 60 mil mark. So then it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. So in this case, we are going up by ones. The bottom of the meniscus is right here. And so that's where I want my value to read. So it's 51, 2. So we know it's at least 52. And here's where our estimated value is going to be a little bit different. We know it's 52, but it's below the 53 line. So what are we going to estimate as the next decimal place? For this one, I'm going to go ahead and say that it's at 52 point, maybe 8 would be a good estimate for that one if you put 0.9 or 52.6. And that's the importance of remembering to add an estimated value. Because when you're measuring in the laboratory, the last number you write down is said to be or assumed to be your estimated value. If you were to just write 52 down, then you would be saying that you're not sure, because it's plus or minus whatever your last value is, you're not sure if this is 52 plus or minus 1. What you're saying then is that it's either 51, 52, or 53. Well, we're pretty sure that it's not all the way down to here, because that's 51. I'm sure it's not all the way to 53, because I can see it below that value. So we want to have our last digit is the estimated one. So what I'm saying by writing 52.8 is that it's 52 plus 0.8. Oops, let me erase that and write it a little bit clearer. 52.8 plus or minus 0.1. So that's really saying that it's 52.7, 0.8, or 0.9. And I think that gets us really, really close to the true value. All right, let's take a look at another graduated cylinder. This one is actually much smaller than the other one that we were looking at. This one has markings of 8, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's only going up by 1 milliliter compared to this one over here where it was going up by 10 milliliters. So each of those lines is not going up by ones, but going up by 0.1. So if this happens to be 8.1, 0.2, 0.3, 0.4, 0.5, 0.6, and this is 0.7, the meniscus is below 0.7. So I'm going to say for sure that I know this is 8. It's going to have a decimal place, 0.6, because I know it's above the 6. I don't know, though, whether that would be a 0.6 halfway in between, or maybe someone else might say it's 0.867. So I'm going to say my estimated value for this one is 0.865. Now keep in mind that's saying that I don't know whether it's 8.64 or 8.65 or 8.66 because you're estimating the last value. So it's a plus or minus 0.01 on this one. If, when I was reading this graduated cylinder, I just wrote 8.6, then that's saying that you're not sure if it's plus or minus 0.1. So that would be saying that you think that the value is either 8.5, 8.6, or 8.7. And I think it's pretty clear that it's not 8.5 because that would be right here, and it's clearly above that level. And it's clearly not 8.7 because that's definitely below this marking. And so that's why we keep this estimated value right here as our estimated value. Okay, one more graduated cylinder. Oh, again, just making sure that when you are looking at a graduated cylinder that you're trying to determine what each of the lines means. And it's going to be different based on which graduated cylinder you look at. The other thing is make sure that you go down to eye level, measure from the bottom of the meniscus, and add one estimated value from whichever lines are present.